Hi, welcome to the next channel. So hope you remember long back I shot some couple of videos on my DIY RO or reverse osmosis water filter. I thought initially to control the water filter with Raspberry Pi. I did manage to build partially, and then I need some parts I ordered in AliExpress. So it took a long time, and then eventually I got a couple of them, and in which one of them was damaged and stuff like that, like this flow meter and stuff like that, including TDS sensor and stuff. So I didn't ever had to catch up, and then I just discarded half the way. And meanwhile I was also quite busy with my client projects and stuff like that. So recently I thought let me just give a try, and this time I thought let me just not complicate. I just do a sort of sequence where it kind of mimics like a washing machine wash cycle, or dishwasher wash cycle. So it just starts the RO and fills it for a certain amount of time, and meanwhile it sends some type of notification in a buzzer and stuff like that. So optionally I can even control in UV to disinfect the water, or I can even heat the water with a heater and stuff. So I did this time with Arduino. As you can see here, I just put everything inside this box. You get this type of a box as a sort of you can build your own DIY external plug points like this. This is by no means it's a spike buster kind of intended use. It is meant for sort of extension or external switchboard, where if it is not wall mounted, you can just build this and then you can screw it to the wall. But it's a nice case. As you can see, it's a plastic body, and you can use this as an enclosure to build any projects like this. Even you can incorporate any LEDs and stuff. So in this case I'm supposed to get this blank plates and cover these two slots. As you can see, there are a couple of ports to which I connected I fitted with this Indian style socket. So you can fit this with any type of socket. As you can see, this can accept even this US 110 volt plugs and stuff. So it has a relay, and of course you can control the relay with Arduino. I can just open it and show to you guys. And besides I need some type of buzzer so that I can sort of notify. Of course, if it is a Raspberry Pi, I can even send some I can even design some type of a UI and stuff like that, and I can monitor via browser. And of course I can even more than that, I can even control it via browser and stuff. Versus this, I need to somewhere compromise the feature, but at the same time, since it is microcontroller, it is far more simpler. So I thought to use some buzzer, which you get it in any automobile shop, something like this. Yeah, some type of a piezoelectric buzzer you can use. You can see this. Okay, you can use this as well, but I'm kind of concerned. If I use this, I'm worried that the amount of current required for this relays, as well as this buzzer, as well as to power this Arduino may not be sufficient. And typically these are meant for 12 volt use. So I'm not sure how far it is going to be audible in 5 volts kind of a situation in this case. So this Arduino, of course, you can power it with standard USB, or you can also use DC barrel connector. I'm just going to open this case so we can have a look inside. I have finally wrote the software, and I have done some cycles, and I was able to finally complete the software and able to test, and everything works fine as intended. See, this is by no means it is meant for any it's not meant or intended for any serious implementation. It is a simple construction. I just want the way I want. You can of course modify, you can add more features and stuff. So I'm not worried that what it lacks and the stuff. I just want it very simple and basic and reliable. It just works as intended, and it is not any sort of hobby project or something. This is a serious stuff. I just want to control my RO, so it kind of fills that canister. I got a fairly large canister, and it has to fill that canister whenever I just turn on, and it has to send notification, and then it just need to turn off. Okay, so that's what is its intention. Okay, yeah, let me just pop open this cover. Yep. Yes, so as you can see here, I finished connecting this relay finally to this sockets. It is, you can see there, this socket I can connect it to the RO filter, and then this socket optionally I can connect it to any heater or some type of UV disinfectant lamp or something like that. But it is, for now I'm not using this, but although it is functional, I can program it whichever way I want. Other than that, I have one of the relay I'm not currently using. I can just control any LED or something like that with that. I'm not sure, but I'm using all the three relays, and one of the relay I'm using for this buzzer. So I found this calling bell laying around. This is not something I bought for this project, you can see there. So the interesting aspect of this type of calling bell is it has a sort of aluminum bar, like a sort of xylophone. Let me just pop open its cover, you can have a look. Yeah, so you can see there it has two aluminum plates, you can see there, and it has this coil, and when the coil is energized, this works in standard lifespan voltage, which is in India it is 220 volts. So when it is energized, it is going to strike this way, and it is going to make a quite audible sound. Although I can't do this, but when it is fully operational, it is going to be quite loud. So I just put this cable tie so to reduce the noise. Of course, I can add some high value resistor. I can just limit the current and then reduce its impact or intensity of that impact, but I can also do alternatively. I just put this simple cable tie, and this is going to dampen some amount of loudness. Okay, so this is what it happens. Optionally, if you don't want to, maybe you can remove one of this bar this way. You can see there it is mounted with this rectangular rubber inserts. You can remove this bar as well. You can keep it one side, or you can just use it as it is, and then you can use some means to dampen this noise. Okay, so even you can adjust the tightness of this cable tie, and then you can reduce its volume. So this is what it is. You can see there I am interfacing this relay board, and I just put this hot glue just sometime before shooting this video, so that nothing is loose when I move, transport or something like that. So it is just everything is well seated. So you can see there the relay has quite a simple this thing. In case if you have ever if you never worked in any relays, it's quite simple. You just need to connect the ground reference and then VCC. So you can pull over here in Arduino. So this is your VCC and ground. You can connect both of them, and other than that for control you can connect to either of these ports, output and input ports. So in this case, since it's a relay, it is just going to get this as an output. So I just connected to this pin 8 and then 4 and 2. So this outermost or the left hand side relay is going to control this buzzer. Like I said, you can use some type of piezoelectric. If you use it, is even more compact. You can mount it somewhere here or here, and then you can pack all within this case. But in my case, I just want a quite loud bell, but again it should not be too loud as well, so I just did this way. So you can see there, I'm just going to do the software or my code walkthrough so that you can have a look, and then you can also take this as an inspiration, and you can build something for any other alternate project. But this is not any hobby stuff. This is really I'm using at my home. I need some type of controller, and I'm not ever going to remove this Arduino, and it is going to be dedicated for this purpose. So you can see there, what I did is, the lives main is connected over here, and from there it is going to be connected to all these switches, and in each case it is going to be tapped and then connected to this each socket, and then one of them is connected to this buzzer. So like I said, since it works in lives main voltage, you can just put this way and make it bit modular. If you don't want the buzzer feature, maybe I can just do this way. I can just disconnect, and then it is going to be fine. It is still going to work just as a controller for this RO. Okay, so this way you can decouple this calling bell, and this way it kind of still going to work. So I can just reattach, and what I can do is I can just energize or connect this Arduino to a power bank. As you can see, this is my Xiaomi power bank. So what we can do is we can just connect it to this power bank, and as soon as it gets connected, I notify the buzzer. I notify through the buzzer, and then I start the cycle of turning on this socket, by which it turns on this RO filter as well. So that's what it happens. Before I walk through the software, I can just do a very quick demo. Of course, you need to connect this standard mains plug. So once it is connected, the entire stuff will be energized, and it is completely isolated. And if you are very new doing any of these projects, be very careful, because this side you have the lives main voltages versus this side you have all this low power circuit. So by no means you should have any type of connectivity between them. So you can cross check once everything is done. Test it with your multimeter twice, thrice, any number of times, and make sure nothing is wrongly connected, so that by no means whatever the lives voltage stuff is not connecting or touching anything over there. And again, make sure you can pot like this with a hot glue, so that nothing is loose, and it is moving around when you really mount it and deploy this type of stuff. Okay, so let me just put back this cover, and let me put some couple of screws. Let me just connect this to this power bank, and yep. Yes, as you can see here, initially it does this notification, and then it activates this socket, and we can even test this socket by plugging some type of a lamp or something, so that we will know that this is now on. Okay, like I said, this has not been programmed, although it is fully connected inside, it is not programmed. Okay, so just let me grab a lamp, and we can test this socket as well. Great. See, I got this small LED lamp. We can just plug over here. So before that, I can just disconnect, so that it is not on. Okay, and we can connect it here. So like this way. So yep. So you can see there it is connected. I can reconnect this Arduino. Yep. You can see there the lamp is turned on. So In some cases you can actually use this as it is for other projects as well, which is why I did, so that it is also sometimes multi-purpose. We can even control any motor or something like that, any pumping motor, or if it is meant for plants or irrigation or something like that, you can still use this basic concept, and you can program it accordingly. So all I want is some type of notification every 10 minutes or so. The canister may take around 70 to 80 minutes roughly to fill completely, which is around 1 hour and 10 minutes to 20 minutes. Okay, so what I did is, in the code I inserted multiple places some small notification. Since this is not a continuous buzzer like this, it just makes that noise every time that pin strikes that bar. Okay, so that is why what I did is I programmed in a way that with a certain delay, each time that relay is turned on, and then it strikes, and then it turns off. Whenever it turns off, again it is going to strike this bar behind it, just like any calling bell. But if you use the buffer, if you use this buzzer, you can program it accordingly. Okay, so this is what happens. So what we can do is, we can do a very quick walkthrough of the code, and then that should give some type of an idea in case if you are intended to build something like this. Okay, I'm also going to share some rough diagram of this pinout and the stuff. It is actually, like I said, it is fairly simple. Any relay module like this, if you buy, you have this VCC and ground. So once you connect it to the Arduino, and apart from that you have all the pins, you can choose whichever pin on this relay, data pin, you can connect to Arduino, and then based on the pins you connect, you can write the code as well. Okay, well, as you can see here, this is my code. It is fairly simple, and you can see I have defined all this defaults. I just declared the second as because it is milliseconds or so. I just declared a second is so and so milliseconds, and minutes is a second into 60 times roughly. So although it is not accurate, it is still going to solve the purpose, because end of the day I'm not just having any high precision use case here. I just need to turn on the pump and for a so and so period, and then it should turn off by itself. So this is what it is happening, and if needed, we can also put a half a second timer as well. So these are the things, and sometimes if you want to debug, you can just disable this, and then you can enable, so that you can mimic a second as a low duration timer, so that you can see everything is cycling through. And then you can come down. I just defined the relay on is low and relay off is high, and then you can see there, these are the pins I am using. This is for this filter, which is the socket, as you've seen earlier, as you saw earlier, the LED whatever I connected to that socket. So this is the pin, corresponding pin, and then this is the buzzer or the bell, which is pin number 4, and the heater, or you can connect any UV lamp or something like that to this pin. So currently I'm not using this, although I have defined, and then we can initialize, and this is the main loop. In the main loop, I just initializing here, I'm setting everything is off before it starts this cycle. And here what I'm doing is, I'm keeping a global variable as cycle equal to 0. So the first time ever this it comes code inside this loop, it's going to be this if condition. The next subsequent iteration, it is going to just stay over here in an idle situation. So here what it does is, initially it is activating that buzzer. Like I said, since it is a calling bell, I need to do this type of PWM type of situation. So I need to turn on, and then I need to turn off. I need to turn on and turn off in this multiple in this sequence. Okay, in this series of sequence. If it is a buzzer, you can just turn on, and then you can turn off, and with a sort of a delay, whatever the duration you want. So you have any piezo buffer, you can just replace this with just a couple of lines of code with a delay in between. And then you have this main RO filter cycle, I'm just running this for loop, and you can see there it is around it is divided into 8 portions. So 0 to 7, which is 8 portions. You can see there 0 to 6, which is 7 portions. It is just going to turn on this relay, which is meant to turn on that socket, to which if I connect the RO filter, it is going to turn on that filter, and it is going to pump the water out. And then I have this delay, which is a minute into 10 times. So to 10 minutes it is going to stay in this state, and then after that it is just going to activate that bell couple of times. In this case I'm just doing once as a notification, and then again it is going to iterate this loop. So once this is in the last iteration, you can see there I less than 8, which means the last iteration is I equal to 7. If it is the last iteration, I'm turning off that filter, and then I'm activating this notification bell few times. So since I don't again have buzzer, I need to do in this sequence, I need to turn on and then turn off, turn on and turn off, and so on. Okay, so 3 times I'm doing this. This is to notify that entire cycle is complete. Versus if you again have buzzer, instead of this you can turn on, keep a delay, and then turn off. Maybe you can cycle couple of times so that it notifies that the entire cycle is over. So some type of a long beep or something like that. So once it is all over, I'm once again to make sure I'm doing this power off of that RO filter. Although I have done here, I'm just doing one more time to make sure it is not on. Okay, so once it is over, it is going to increment this cycle. In the next subsequent loop iteration, it is not going to do anything. It's just going to sleep over here. So it is second into 1000, which is it's a long infinite wait. I can even change this into a minute into 1000, something like that. So it is going to be a long infinite wait. So this is what the code is. So like I said, I thought earlier to do something with a Raspberry Pi, but again I was not getting any time, but I need something like this in a real use case scenario. So I thought, let me just compromise and do something quick with Arduino. Most probably if I have that heater arrangement or something like that, all I need to do is I need to just copy paste this cycle. So once this cycle is over, I can mention as if cycle equal to 1, then do that heating cycle, and then I can just stop everything, and then I can keep this long indefinite wait, something like that. So of course I can improve this code and stuff. I'm not much familiar with Arduino code, so since I'm well versed with systems software development and C programming, I just mimicked generally what I do in C. I'm not sure if this loop can be terminated and if the program can come out. I'm not really sure. Since it's a microcontroller, I don't think so. It's going to loop around in this API. So I need to do something like this so that it is going to be a sort of passive wait once all this the main cycle is complete. So this is the intent. Like I said, it is quite simple. You can just change anything accordingly. In case if you are using this controller for some other purpose, you can just modify this code. In case if you are interested, you can request me. I can send this code, or maybe I can even attach this code or provide Google Drive download link, or I can just attach it in my website so that you can directly download it by clicking the link in this video description. So hope you enjoyed this video. If you have anything to discuss, be in touch via mail, or if you have any small query, you can discuss in YouTube comments. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.